Let's start maybe.
Yeah.
Welcome everyone to this informal session to inform you about our program on health data analytics and machine learning. So I'm Professor Mark Shadow-Hyam. I'm the director of the course, and you also have online Sabrina, you can just say hello, who's the co-leading the and organizing the course with me. She's the senior teaching fellow in charge of the course. So I'm very pleased to give you more detail about the course. So maybe we can start now. If you could flick to the next slide, please, Sabrina. Yes. So, ooh, you're going way fast. So yes. So we developed that course 5 years ago, when we delivered the first iteration in 2018, if I remember correctly. And we had a strong objective that we realized that the use of advanced statistical and machine learning algorithms in health sciences was not optimal, in the sense that there were some methods around that were very efficient, very useful, and providing very informative results, and that we could not see that those were exploited as much as they could in health sciences. So that was one first observation. And we also realized that there was a reservoir of very, very talented and knowledgeable students from a more theoretical background that are not engaging enough in health sciences. So basically our idea was to try and form a multidisciplinary culture on health data science that would combine the advantages of both more biological / epidemiological / medical students and more theoretical students, so that they work together into trying to formulate important, relevant, and challenging research questions in the domain of health sciences, and use state-of-the-art and develop novel approaches for exploring these complex data sets. So, as I said, the target audience of our program is really focusing on multidisciplinarity. So we want to attract students with strong methodological backgrounds, so typically students with mathematical, pure statistics, for instance, or econometrics students who are willing to move to health sciences as an applied field, as well as a strong student with a background in epidemiology, medical sciences, biological sciences, willing to learn on how to make the most of data they're familiar with, and how to integrate complex, high-dimensional, and highly complex data sets. So basically, the idea of the entire course is that we want to create a cohort of people that have, by nature, very different backgrounds, but they're able to work together and to come up with questions and answers together. So in a sense, we summarize our objective and our approach as we don't want to train experts, but we want to train experts, but not nerds, in the sense that we don't want to have people knowing everything about every single possible algorithm, but we want to have people that can make educated guess on what type of algorithm they should use in which case, and what is going to be the most promising and the most informative way of looking at the data. So again, here our objective is not about technicality, it's really about expertise and know-how. Next slide, please. So, as I said, the first cohort was recruited in 2018, where we had 17 students with a nice mix of scientific backgrounds, most of whom are currently pursuing academic jobs, although not all of them wanted to start with to continue in academia. Some of them were kind of converted after the course. Then in 2019, our second cohort was recruited. We received over 200 eligible applications and recruited of these 27 students from 10 different countries, with a background including medical doctors, mathematicians, biologists, engineers, epidemiologists. So a nice range of students. 2020-21 was the largest cohort so far because it was online. And so we received 600 applications. Of these, a bit more than a half were eligible according to our criteria, and we made 63 offers, which converted into 43 students. Last year's cohort was 36 students. We received over 400 applications, of which a bit more than a half were eligible, and we made 57 offers. Next slide, please, where we're going to describe the current cohort so that you have an idea of the steady numbers. So we have received quite a few applications this year as well, over 500 applications. Again, same proportion of eligible application. We made 64 offers and we enrolled 34 students in the end. So just quick descriptive. We're quite proud of having an overrepresentation of women in our students. We span 14 countries from Europe, Middle East, Asia, and the US. Background of the students, as usual, and as wished for, include mathematicians, statisticians for a big part, engineers, people with human sciences background, epidemiologists, biology with some of them with a more focus on molecular biology, pharmacists, and medical doctors. So the large range of backgrounds were recruited, and also nicely we have a large range of experiences. So age ranges are also quite large, with students coming straight out from their BSc, or also having people that are professional taking a year off for a career switch or for training purposes. So we were quite happy every year, and specifically this year, to have been able to recruit really the multidisciplinary but also multicultural cohort that we are hoping for, and that is making one of the values of our course. Next slide, please. So I'm going to walk you through how a year is broadly organized. So basically we have 3 terms. The first term, that is October to December, which is quite populated in terms of module teaching. So you've got 4 to 4.5 module taught days with half or a full day of independent or study work on the Wednesdays. But on these additional days, you have some additional teaching resources that are organized, including journal clubs, including additional practical tutorial and seminars. So typically when students report they struggle with some concepts, or that they want to know more about one feature of the course, we organize bespoke additional sessions to make sure that everyone's on the same page, because that's the term where people with their different background needs to learn to speak the same language. So we need to keep everyone up to speed. So that's what we use these 3 days for. And there's also some student presentations on that 3 day. Next slide, please. So in practice, this is the term 1 module. So you have, as I said, this is a building up module where people with a more methodological background will learn more about biology and epi, and conversely, people with a more biological or medical background will learn about more statistics. So you have, in that respect, three modules that are dealing with this. Then you first have the introduction to statistical thinking and data analysis, which is led by Jeff Eaton. So that's a module that aims for you to understand the basic statistical concepts that are routinely used in EPI. This is a module that is shared with another program from the school, the Masters in Epidemiology. We have the principle and methods of EPI, which is also common with the MSc in epidemiology, which is led by Philippos Philippidis and Amanda Cross. Sorry, I forgot to add her name on the slide. Where basically the main methods, study designs, and concepts of epidemiology are introduced or rehearsed for those who already know them. And then the third module, which is also the catching up module, is the molecular epi module led by Dr. Degen, where basically there's an introduction to what molecular epi is. And so you will see in that module the different types of omics data that you can encounter routinely in health sciences. What are they specific, how you can explore them, and how are they relevant to health sciences. Now, there is a more technical module led by Sabrina called Clinical Data Management, where basically you will learn about how to design, query, maintain a database, but not a database in general, but a database that includes health data. So that means that you will be made aware of all the constraints and both legal, security, and ethical constraints that your database should adhere to. So that's a very important module that really helps you understanding the specifics and the complexity of the data and their handling. Then there is another module which is spread across two terms. So that's the translational data science module, which is also led by Sabrina and Verena Zuber, where basically in that first part, you will be introduced to practical aspects of conducting rigorous, transparent, and reproducible research. So the idea here is that to get you prepared for term 2, where that module will be more about analyzing data. So in that first part of this module, sorry, it's really about good practice for coding, reporting, and being able to reproduce exactly your results. Next slide, please. So then you have the term 2, where you have still a rather dense schedule, where you've got 3 to 4 days of module teaching per day with machine learning. On the Tuesday, you've got the 2 5-week modules that are implemented. Then you have seminars, then you have computational epi, and then you've got the second part of TDS that I will describe in a few minutes. Research project allocation, which is what is going to keep you busy after the taught terms, starts in term 2, where the list of projects are being populated, given to you, and the allocation is happening in term 2. Next slide, please. So I mentioned already the names of the modules. So these are more specialty modules, and that's the term 2, which we tend to call the more advanced or the specialty term, where basically you will be learn more about machine learning. So that's a module that is led by Dragana Vukčović, where basically you're going to be introduced to most of machine learning algorithms and how they're implemented. So that includes decision trees, SVM, and pure prediction models, including neural and Bayesian networks. But not only will you learn about the algorithms and what they can, but you will also be taught how to apply them, how to understand the output they produce, and more importantly, what are the limitations of these approaches. Then a companion project module of this machine learning module is the computational epidemiology module, which I lead, which is, if you want, exactly the same, but rather than looking at machine learning algorithms, we more discuss about statistics and statistical modeling. So the idea here is that you will learn, again, using a data application approach, how to understand, how to implement, and how to interpret the main methods that you could be using for analyzing. We're taking examples from molecular epidemiology, but all these methods can be applied to any population health questions you may have. So that includes variable selection, that includes network inference, and so on. So this is, if you want to those 2 modules are where you're learning specifics and more advanced techniques to be used in health sciences. Then these 2 modules are accompanied with the second part of TDS, which is so you've seen the know-how and the more technical aspects in term 1. In term 2, that module will walk you through from getting data sets, so getting your data, formulating a question, and through all the steps, applying all the methods that you've been taught in machine learning in computational EP on a weekly basis, and apply them to your data for your specific question. And you will be, as I said, walk through all the steps from data gathering, curation, cleaning to paper writing during that term. And you end up with a report at the end of the term that is paper formatted. And for instance, last year there was one paper that we are about to submit that results from this work. Then you have, in parallel to this, more specific methods that you're going to be introduced to. So that's the advanced analytics module, which is a module that is starting actually this year, led by Monica Pirani, where you'll be introduced to time series analysis, hierarchical modeling, spatial temporal modeling, as well as disease and epidemic modeling. So these are 5 weeks where, again, we're taking the approach of giving you the methodological and theoretical background, and also have a strong emphasis on the implementation and the application to real data. So this module is prerequisite for the last module, population health analytics, led by Professor Izzati, where basically you're going to be introduced to the main goals and challenges of the research for population in global environmental health research. So you will apply these methods, or you will see application of the methods taught in advanced analytics in the literature of population health. Next slide, please. So throughout these terms, there's a lot of, I think, that's not, yeah, there we go. So throughout the year, you will be exposed to many project work, and that's one key highlight of our program, is that there's a lot of more or less demanding project work that we ask you to complete, so that we make sure that all the theory that you're exposed to has direct linkage to applications. So within each of the modules, you have some projects. So you have some small toy example data sets to play around with at each during the practicals, that helps you illustrating how you could use a method that you've learned in the morning, how to apply it to real data in the afternoon. So that's the general approach for the practical work. But also you have within module projects that are usually done in groups, where you're asked to make a mini analysis or a mini research project, if you want, in groups, making the most of the methods that you've learned in the different projects. So that's the case, for instance, in Compepi, in machine learning, where you are given a data set, a question, and you're asked to design your own analytical plan to implement it and to interpret your results. Then you've got a bigger chunk of project research in TDS, as I was mentioning, so that will take you through the whole term 2, where you have groups, you are allocated in groups. You have a real data set with an unexplored real research question, and you're asked to do everything from compiling the data, cleaning it, imputing when needed, making sure it's all exploring, making sure that the quality is fine, to formulate your research question, translate that research question into an analytical plan, implement that analytical plan, interpret it, and write it up as a paper. So that's the translational research project in term 2. And then, of course, you've got the term 3 research project, which is, I don't remember, well, it's 4 months pretty much. This is, of course, individual work. You have a real data set. You've got a real research question. Some of the projects, well, a large fraction are aiming to be published. And we have some examples of work that has been conducted that came up as an interesting paper. You're supervised by a data expert, so pretty much the group that is providing the data is supervising you to make sure that you have the right questions and that your results make sense. And this is evaluated through a presentation and a report at the end of the term 3. Next slide, please. Yeah, so basically the module projects come from real data. So we take, we have ongoing research projects. So we use that data to ask you questions and you to analyze this data. So that we take the example of Exposome project that we're involved in, but that also was the case with the UK Biobank. And so you've got quite a few real data sets to play with. In TDS, same, it's a real data sets with, again, real questions that are usually data that we host in the school, but sometimes it could involve external partners. And then the individual research projects is very, very diverse. So usually we propose a list of projects. So last year we had over 70 projects to offer to our students. Again, real data sets with a real and topical research question. And these projects are either supervised within the department or within the school, could be supervised by colleagues in other departments of Imperial, and it could also be projects that are supervised externally and internationally if interested. So this is very, very broad. And just before you ask, these research projects could also be student driven. So we have students that come, have a strong idea of what they want to do during their year or next. And so they know what would be a nice skill to get. So they come with a very precise idea of what they would like to be doing. And so we make sure that if they don't, even sometimes they know with whom they want to work. But if they don't, we help them populating a bespoke project that will maximize their exposure to what they need for the next steps of their careers. So the only thing we do when we take projects that are not in our list is that we make sure that these project ticks the boxes of the learning outcomes of the program, and we usually offer some additional support and supervision when needed. Next slide, please, Sabrina. So these are just examples of a research project that we've provided. So of course, it's no big mystery. We were involved in many COVID studies. So there was a few projects on looking at the dynamics, severity and risk factors of COVID-19 using different data sets we had access to. There was more molecular epidemiology projects on molecular phenotyping of chronic conditions, for instance, but also looking at biomarkers. There were also a wealth of projects on population health, looking at exposure modeling, characterizing hospital responses to epidemics. So all of this could also be offered. There were also some projects in infectious disease to model disease outbreaks. There were more methodological projects. So for instance, in the field of machine learning, there were quite a few projects on developing interpretable machine learning approaches to analyze certain conditions. There were quite a few projects on image processing, image simulation and analysis. And of course, there was a wealth of projects trying to devise some efficient predictive models. To be mentioned, most of the projects, because of the wishes of the students, were hosted in other universities, but we also have enough industry-based projects. So here are a few companies that usually offers projects. So Visa, for instance, the big pharma as well, so AZ, GSK, and more smaller startups as well. So we've got a wealth of companies with whom we have nice relationship that can offer, that usually offer projects for you to spend your summer on. And as I mentioned before, there's also a student-initiated project. So either you come with just a rough idea of what you want to work on, and we help you understand and identify who could be your supervisor if you want to work on, say, neuro imaging. So we can put you in touch and devise with the relevant department the right project. Or if you know with whom you want to work, we can put you in touch and try and help in developing a bespoke research project. Next slide, please, Sabrina. Okay, and finally, there's a few additional resources in the course that our students are quite happy with. So there are some optional teaching, so usually in term 1. So it's again for helping that we have a harmonized cohort by the end of term 1. We offer optional mathematical refresher, so mainly looking at linear algebra and basic matrix operations. We've got the corollary of this, which is the introduction or refresher on molecular and cellular biology. And then later in the term, or actually that one is in term 2, we have some focus on some algorithms that are not seen in detail during the term, including, for instance, the MCMC algorithms. One point which is important is that we have a series of seminars. So you've got journal clubs, you've got departmental and school seminars that you are more than welcome to join. But there's also HDA specific seminars where we call them student-led journal clubs, where basically the group of HDA students are asked to prepare a presentation on an important or a seminal paper in front of the main author. So it's usually an hour where the students present, ask questions to the main author, and the author asks questions to them. And then this is followed up by a second session where the main author is presenting a follow-up of this work. And so that's usually a good opportunity to see how science and how research works in practice. So what's the becoming of a scientific finding or a method? How do you extend it? How do you use it in real life? And also it's a very nice opportunity for the students to network and to discuss with international experts in the field of health data analytics. There's also a series of keynote lectures that are organized in the course where you are where you are invited, of course, and where you are invited to discuss and network with these people who could be people you might want to link to for your future career. So with that, I think I finished my overview of the course. So if you have any specific questions, just feel free to shoot them and we'll answer them. I think you're on mute, Sabrina.
Yes, there are some questions. I'm just trying to find, sorry, this keeps on changing. Oh, here we go, Q&A. So some of the questions have already been answered by our postgraduate education coordinator, Joel, but there are some others that are still open for exploration. So what level of programming is expected of students from a biomedical background to become a strong candidate?
We have no prerequisites. I think we think the course is self-sufficient. Now, just so you know, we're mainly using R first and Python. We're strengthening the Python component, but and you don't have to be an expert. Obviously, if you've coded in R already, if you know how it works, you will find some of the lecture easier than some of your peers. But the course is designed so that if you don't know, with the additional resources, I forgot to mention that among the additional resources, there are some R introduction to R or quick start guide to R that are implemented that can help you getting up to speed. But short answer, no prerequisite, but we're using R extensively. We're using Python quite a bit. So if you know it, it's just going to be easier for you, and you will have time to focus on something else. But no prerequisite. And if you don't know how to code, at the end of the course, you will.
Yes, and before the students start on the course, a few weeks before, we send out some additional information with some links to resources for those people who don't have a lot of knowledge, so they can start getting their head around coding and being introduced to it. So we've generally submitted links and resources to R, but this year we're going to complement that with additional resources for Python as well. So just before you start, so not months ahead, but a few weeks before, just so you can get into the mindset.
But again, just wanted to reinforce that these are additional optional resources that are mainly here to make sure that you feel comfortable, but they are not compulsory, and the course is organized in such a way that if you've not done this, at the end of the and if you follow the courses, then you'll catch up in due time. So this is just for you to basically relax and see what's going to happen. So this is nothing compulsory. And same goes for the stats, and same goes for the molecular epi.
The next question is, so for the personal statement, what kind of skills or experience are you looking for in particular?
So that's a good question, actually. We're not looking for the specific skills, because really what we want is people for whom our course is going to be a game changer and is going to be something that makes sense. So that's really what we judge in the covering letter. So of course we select you on the basis of excellence and so on, but in terms of skills, there's no prerequisite. As long as we are convinced by reading your statement that doing our course is going to be useful and is going to be what you need based on what you did before and what you want to do next, then this is the utmost convincing statement you can make. So we're not expecting any well, of course, the more you've learned, the easier it will be for you, but we have recruited, and they have been very successful, including some members of staff now that were in a totally different field. So people working in the book and in the publishing industry and so on. So it's not really about, it's really about MV and vision of what you want to do.
The next question is, would I be capable of applying machine learning and creating algorithms in health research after finishing this master's?
Yes. So that's an easy one. Yes. Yeah. Well, that's exactly it. That's there's a huge variety of applications that you can, or jobs that you can take after this. Some could be just being a data analyst, having data sets to analyze, and irrespective of the framework, whether you stay in academia, you go in industry. So it could be that you are an expert in knowing what to use, or it could be that you take the more methodological angle to it, and that you'd be the one saying, okay, I've got this algorithm to look at these kind of problems. I think these are suboptimal. If I change this, and if I change the algorithm this way or that way, that could be better. So there's also some, at the end of the course, you'd be able to be more on that methodological side, if that's your question.
And then, so the last question that we have here, but I imagine we'll have a few more. So for molecular phenotyping, does that relate to metabolomics?
It includes metabolomics, yes, but not only. So it's really about understanding the molecular, or and by molecular I'm saying gene expression, methylation data, proteome, metabolome. What are the molecular characteristics of people that are related to either an outcome or an exposure? So we're interested in both the, if you want, the biological response to external stresses, as well as biomarkers that are associated with a change in the risk of certain conditions. And that's exactly what the computational epi module is about, is to look at what are the algorithms and methods we could use to explore these data in depth, one by one. So doing a metabolome-wide association study using advanced techniques and identify sets of metabolites that are dysregulated in relation to an exposure, for instance, but also look at how to integrate the data from metabolomics data, gene expression, proteins, and so on. So that's the whole thing about that module, is to grasp that complexity.
The next question is, so if a student applies later, say around February, does that jeopardize their chance to have an offer?
So it's an open process. So basically, and we can't accommodate more than 45 students, so we have a limited number of seats. So the later you apply, the less seats there are left. Now February is fine. Yeah, but I don't know what the future will tell, and it changes from year to year. But usually in February there's still some room free. But I think if you're a bit unsure and so on, you can get in touch directly with us, and we can discuss.
The next question is, so what do our graduates go on to do after their degree?
Okay, so there's a good fraction of our students that continue in academia. We're currently creating an alumni, so we will have precise figures soon to share with you on the becoming of the students, but quite a few of them are moving to a PhD. Some are getting back to the job they left, or they go for the next step in their career. So we've got quite a few students that go to industry, banking, pharma, as well as small to middle sized startups. So a large range of industry. So you have a very, very broad. Well, to be honest, the becoming of a student is not really an issue. Most employers are quite happy to recruit our students. So the perspectives are very, very wide and open.
So the next question, I can help also to answer this, but I will let Mark answer first. So will the course look at electronic health data records?
It does. A bit in the modules, but we have quite a few projects, actually, a summer project, that are looking at these kind of data.
Yeah, so we cover a little bit of electronic health records in clinical data management in the last week, but this is just to give an overview to electronic health data records, because a lot of our students aren't familiar with this, and we have access to some of the electronic health data records as well. And as Mark said, so that is then used in the projects.
And you've got quite a few. We've got colleagues in the school who are expert in analyzing the group of Paul Eileen and Alex Botto. They're working on this data, and they offer quite interesting projects every year.
Okay, another question. So is machine learning about the physical machine? How does it associate with data analytics?
I'm not sure I'm getting the question.
So is it about the physical machine? So it's not about the physical machine, it's about the methods that are developed in machine learning to analyze data. So it's not about learning about the machine. So
basically, the field of machine learning is a field of data science, where basically you let the machine learn from your data some information that is then subsequently used for prediction. Pretty much that's the scope of machine learning. If you prefer, it could be called, although I'm not a big fan of the expression, it could be called AI.
I hope that answers your question. Is there a basic level of maths proficiency all students would be expected to have, including those from a medical background?
The level for medical students in math is enough. Again, it's going to be the more advanced you are, the easier term one will be for you. But even if you're not confident, or if you're not as solid as you think you should be, then at the end of term one, you will know what you need to know to go on to term two.
Yes, so this links with the next question. So there's the intro to stats module and introduction to statistical thinking and data analysis. So that will give you a very good introduction to statistics. And then there's also the optional linear algebra sessions as well. And that will give you an introduction and a good understanding of the matrix algebra that's required to understand the methods that you're taught in term 2. So then another question is more around the application process. So when will the application be reviewed in the system? At the moment for this student, it says it's completed and went to the department. So it just takes a little while for the application to go from the starting point to the end point, but it should be reviewed shortly.
The process is that you make your application, it is reviewed centrally, then it is forwarded to us, then we assess them, and we do that by batch to ensure that we have for fairness. So and so we have batches of results. Depending on the size, it's taking more or less time. But if you've applied, you should hear soon.
Right. So those are all of the questions. Unless someone wants to submit another question in the meantime. Oh, what kind of PhD areas do students go on to?
Well, again, it's going to be a bit of a non-answer. Well, it's definitely on public health and health data mostly, but with different focuses. Again, you've got some students that go on and work really on the method side and developing new models. So basically, they know what is a struggle or what is a bottleneck in the analysis of certain types of data, and they work on developing new models and new approaches to answer these questions, and then they apply it to a data set. So that could be one, or it could be a way more epi oriented PhD, where you would have a study and you're asked to analyze data of the study. So use these more advanced techniques to analyze this and formulate questions. Then you also have some students that go more on the ML or AI side, where they're doing quite a bit of image processing, image analysis, and black box prediction. This guy is very vast, but if we were to identify a common point between all the themes, they all relate, of course, to health data with different degrees of methods and application.
There's another question. Do you accept candidates that already have a PhD?
Yes.
Okay, then the last question is, are you looking at undergraduate transcripts, and does this affect very much the result?
So definitely, as you've seen in the numbers, we received quite a few applications, and we're quite selective. So definitely your transcripts are going to be important, and one criteria that we judge the applicants on are their excellence. So that includes their marks, their recommendation letters, and but so clearly the answer is yes, we're going to look at it, and the higher your marks, the more likely you are to be offered a seat. Now, we also account for, again, this is an important part of it, the statement and why you want to stay with us. But yeah, good universities, well, top world universities and good marks are always a plus.
There is another question. So this person in particular is currently a doctor in the NHS and is thinking about going into medical practice with a view to do clinical research with ML-based tools. And so they are essentially asking, would this course be useful for that?
Well, we've had some students with exactly the same type of background, and they were very, very happy to have taken the course to continue along these lines.
There were also some other questions that were posed before so perhaps we can cover some of those, given that we still have a little bit of time left. So there was a question about, so they have a particular science background, computer science, do they need a health qualification to be eligible? So hopefully by now you know that the answer for that is no, you don't need this health qualification. Then what are the available scholarship opportunities available for international students? So there is on the Imperial website a web page that contains a lot of these scholarships available for international students. But if you get in touch with us, we can point you to that web page.
And this is evolving in time, specifically since Brexit. We're trying to get some more international studentships, which is difficult. But if we succeed in finding some, we will post them on that webpage.
Another question, I think Joe has posted the link in the chat as well. There was another question around the deadline of acceptance for applications. Yeah.
So do you want to answer that, or do you want me to answer it?
I don't think, and we have Joe on the call, so Joe can also help. So there is no sort of official deadline. Well, obviously there is, a week before the course, I believe, and that obviously depends on your condition. So if you're an international student applying a week before the course starts, or 2 weeks before the course starts, that's not going to work because you need to go through the whole visa process. So there is a certain number of seats available for the course, and this is not a hard number. So what we recommend to students is to apply as soon as possible.
Yeah, and general practice is that, well, yeah, the sooner the better, for sure, as you just said. And then for international students, then it's going to be very, very tricky to even if there are some seats left, to be enrolled after July, because the visa process takes a while.
Yeah. And there's another question that relates to this. So do you accept students who are pending completion in another MSc program, or is it recommended to stick to only one program?
I'm not sure. Well, you can't be enrolled in 2 programs at the same time. So if you have a BSc, then you're eligible for applying to us. So if you are doing a master's, you have a BSc, so that's fine. Now, if you are offered a position with us, then you cannot continue the other one. You need to finish the other one.
Yeah, so from what I understand, there can't be an overlap in any of your assessments. So there can't be an overlap in teaching time. There can't be an overlap of assessments if you have outstanding assessments from your previous course. So all of that needs to be completed. But it does not necessarily have to do with the actual graduation date.
No, but you can't be enrolled in programs at the same time.
Right, I think that is it.
Great.
Let me see. Oh, so what is the ratio of local to international students for this current cohort?
Good question. I would I don't have the precise numbers, the exact numbers, but rough estimate, I would say 60-40, 60 plus international and 40 national. Maybe a bit more international. What's your estimate, Sabrina?
Yeah, it's around that, I think. But we can always check this. Then there's another question. When would the final terms project, well, it's not the final because one was just now submitted. Again, when is the final terms project due? will this take us through to September? No. So your project is due at the end of August, starts at the beginning of May, and then you have a project presentation in the second week of September. Generally, this is how this has been done.
But you are enrolled until October. You're enrolled until October. But usually for subsequent PhD, that was not an issue. We always found a way to make sure that you can enroll for the next your next step in time. So there are ways. If the question is about the PhD starting in September, there's always ways around to make sure that you're not that you can still do the next step in time. Across universities, we can found arrangements, if that's what the question.
Okay, I think now there are no more questions.
All right. Well, thanks a lot for your attention. We had a nice turnout. I hope you will have found some answers to your questions. And if you have any further, feel free to email us. And if you need some more bespoke guidance, we can always arrange a call at some point. All right. And again, yeah, if you're interested, the only advice we can give you to optimize your chance is to apply early. All right.
Great. Thank you.
Thank you very much.
Bye.
Bye-bye.